Question 8 says, in the XY coordinate system, if A, B and A plus 5, B plus 2K are 2 points on the line defined by the equation there, then K equals, and you need to find the value of K. So let's see. You can try. So how do we calculate this? Actually, you have, like different possibilities. Did you people use the approach that in order to calculate, the slope of a line whose, like, for example, sample points. Let's say that you have 2 points that are crossed by a common line, and you are given the coordinates. Remember what we did? The slope or the value of m is the difference of y coordinate divided by the difference of x coordinates of the 2 points. So one way could be this, right? You could say, okay, the slope equals the difference of y coordinates, which is b plus 2k, take away b, and the difference of x coordinates would be a plus 5, take away a. So notice what happens, something interesting. You are left with the expression 2k over 5. But at the same time, you already have the equation of the line. All you have to do is simply change the equation so that you can isolate y. Okay? If you isolate y, you get 5y equals 2x plus 9, and then dividing by 5, you get 2 over 5x plus 9 over 5. Clearly, the slope is this coefficient, so this is the same. And from this, you see clearly that k equals 1, right? Oh, this desk is unstable. Well, that's it. So this is one way. There are possibly other ways. Did you do this, or did you follow a different approach? What was that? Well, people, you could try, for example, a totally different approach. Like saying, starting from the principle, how do you know a point belongs to a line? If that point satisfies the equation of the line with its coordinates, right? So if I substitute A and B, in the equation of the line, you should get 2A equals 5B minus 9. This equality must be true. Same goes for the coordinates of the second point. So if you substitute A plus 5 where x appears, 2A plus 5 must equal 5 times B plus 2K minus 9. This is also a true equality because these 2 points are supposed to belong to the line. So what happens if we modify this a little bit? Expanding the parentheses, you have 2a plus 10. You have here 5b plus 10k less 9. Do you notice something? What if we subtract equation 1, this equality, multiplied by negative 1 and add with the equality here? So you would have 2a plus 10 minus 2a equals 5b plus 10k minus 9 minus 5b plus 9. So notice what happens. Away, 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 and then 10 equals 10k. Therefore, k equals 1. So that's another way. So it's not like, all the solutions are kind of rigid. Yeah, if you combine different properties, you may get, different ways to the same, different paths to the same solution, right? Important thing is that you try and think of the properties involved. So using different methods, you can still get the same answer. All right, so that's what we can say about coordinate geometry. Lorena, you have a question or comment?
Yes, sorry, Professor. I missed the last step where you eliminated the two A's.
Yeah, because let's say I have this equation, I call it 2, because this is a true equality that,
Yes.
um, you know, turns out from the substitution of the coordinates of this point in the equation of the line. It must be a true equality. Same I did for this point. This is the
Mm-hmm.
equality we call number 1. So
Yes.
here I'm doing this. I'm subtracting 2 minus 1.
Oh, okay.
Mhm. Yeah, we can subtract equations. Remember, that's one method, for example, for elimination. I'm applying elimination here in order to get rid of the A's, B's, which we don't know, their values, and just be left alone with K, which is what I want to find out. Okay, so that was it.